Please, Ms. Tasneema, you can start your presentation.
Thank you, sir. I'm Tahsina, undergraduate student, Department of Civil Engineering, BUET, and today I will be presenting our paper on estimating particulate matter using statistical modeling methods. What is this particulate matter, right? This particulate matter is particles of aerodynamic diameter 1 to 2.5 micrometer present in our air, and when inhaled they cause cardiovascular and respiratory diseases. They are one of the 6 major criteria pollutants. So our objective was to develop a statistical model to predict or estimate PM 2.5, which will be later useful for air quality or air pollution related policy development. So we developed 3 different models, then evaluated their performance using some criteria, and then chose the most suitable model. Our study area was Chattogram, the second largest metropolitan city of Bangladesh. It is very densely populated and plagued with worst air quality. There are 2 continuous air quality monitoring stations, one in Agrabad and one in TV station. We chose Agrabad as our study area. The data collection and preparation went through 3 steps. We collected 30 input parameters as listed below from Department of Environment and Bangladesh Meteorological Department. Then we cleaned the data. There were some missing values in the input features, so we filled the missing values using linear interpolation. There was one dataset that contained categorical variables, and they were replaced by dummy variables. As you can see below that each parameter has different units. So for uniformity, we scaled the data set between 0 to 1, and then they were split 70 to 30 into training and testing data sets. For analysis, we used MATLAB 2020 and 3 established machine learning methods: Gaussian process, support vector machine, and random forest. Let's see what did we find, how the model actually performed. This graph show you observed or actual PM values in the x-axis and output values or model predicted values on the y-axis. As you can see, the closer to the 45-degree line we will have the values or points, they will be more accurate. But 3 of our models are very closely accurate, but not 100%. They were a little bit skewed. Even from this graph, we can see that the Gaussian process line, the dark black line, is closest to the 45-degree line. So let's see quantitatively how the models performed. We use 2 performance criteria, coefficient of determination, R-square value, and root mean squared error, RMSE value. As we can see that Gaussian process has the highest coefficient of determination and lowest error. So we chose Gaussian process as the So our winner was Gaussian process. But we also wanted to see that, okay, we are using 13 different parameters. Which are the important ones? Or do they all actually matter? We used pollutant parameters, meteorological parameters, everything. So we did a sensitivity analysis. Each time we excluded one parameter and ran the model, our most suitable model, Gaussian process, with the remaining 12 parameters. As you can see this graph, that when PM10 was excluded, the RMSE jumped 60%. Which means for our model, PM10 was the most influential parameter. So we have model Chattogram city. Fine. So what about other cities? Other cities in Asia like us? The other studies show that Tehran, Mocha, Faridabad all showed most predictability in machine learning method. For Tehran, it was support vector machine. For Mocha, it was general additive model. For Faridabad, it was random forest. PM10 was found to be most influential by the Tehran study. but Mokka and Faridabad study showed that temperature and wind speed was most important. This is the summary of our paper. We are confident that machine learning techniques will be most suitable than established or normal linear regression methods for air quality prediction. For our study, PM10 was the most influential input parameter, but our limitation was that we only used one point dataset. We only took the parameters from the Agrabad camp, and we did not consider spatial distribution. Our models only followed the established algorithms. There can be more hybrid models tailored for this air quality modeling purpose. Thank you everyone for listening. Any questions, please ask.
Thank you very much for your nice presentation. At this stage, I am opening the floor for question and answer. Dear participants, you are invited to participate actively.
There is a question also in the comment box, sir. Please.
Can I ask a question, please? Hello.
Yes, I can hear you.
Yes, please, you can continue.
So you tested out your model for every and each different parameter, right?
Yes.
So I want to know what was the difference between your optimum model for PM10 input and for the model you tested out with PM2.5. Because in our research, we found that those two are very highly correlated, so their model should be closer. I'm interested about your.
Sorry, in each case, our output was PM2.5.
Oh, okay.
PM10 was the input.
Got it.
Anybody else? Any more question?
There is a question in the chat. Can I answer?
Okay, yes. What I have found, Mr. Rizvan Ahmed asked you to answer the question, why did you decide to use only these particulate prediction models? Can you please answer this?
Okay, sure. Thank you for the question. I actually use the most established machine learning methods because we are engineers, right? If we are developing a novel method, we will then have some problem with practical use of the model. So I wanted to use the already established methods to see if they are suitable for prediction. If they were not, then I will go for the novel mode. As I have already mentioned in my concluding remarks, then that we can use hybrid models and we can go for the novel method approach. But I think our R-square values are very good for already established methods. Well, we can, for scientific purposes, try to develop newer models for, I think, even better accuracy if we want.
Thank you so much for your nice explanation. At this stage, we have limited time. That's why I need to go for the next presentation. Thank you.
Thank you, sir.